Uh, Good morning, students. There is one thing. This is not for first PU because I can see Shubhangi Singh and some students I can see. This is not for first PU. You people will be having tests today, right? So you don't have the class. So this will be for second PU, not for first PU. Please send the message to your friends that first PU chemistry class is not there. This is for second PU. Okay, na? Which later they will going to see the video. Second PU students. Fine. So you can log out. Whoever first PU students have entered, you can log out. It's not for you people. Okay, na? And all the best for your exams. Do well. Fine. So good morning, Amma. So all of you can log out. You can use this time for preparing for your examination. Fine. So this will be for second year. We are going to discuss about electrochemistry. It's a revision class with related to electrochemistry. Fine. When it comes to electrochemistry, as we have already studied and already we have completed this particular topic, all of us we know that it is related to chemical reactions. It is related to chemical reactions. Okay. Now, these chemical reaction can lead to the formation of voltage, that is current. Okay, that is current. It will lead to the formation of current. Okay, or it can lead to the chemical reaction where it demands the current supply or voltage supply. It demands the voltage supply. So that's where we have the chemical reactions. So there are some chemical reactions. Due to that reaction, there will be generation of certain electricity. Now, for some reaction, they require the electricity to have the reactions to happen. So that's where we have two types of cells. So we have two types of cells. One is Daniell cell. One is Daniell cell and another one is electrolytic cells. And another one is electrolytic cells. Now when I am talking about Daniell cells, once again we have two types. Daniell cell can also be called as voltaic cells or galvanic cells. We have many names for the Daniell cell. Okay, so voltaic cell, galvanic cell or Daniell cell all together. They are related to generation or formation of a reaction due to the chemical reaction. They are going to generate the voltage. Okay, so there will be chemical reaction. Due to that, there will be formation of electricity. Okay, electricity in the sense voltage will be formed due to these reactions. Now when it comes to electrolytic cell, so in this case when I am talking about electrolytic cell, these demands the electricity. They demands the electricity to make the reactions to happen. All of you have understood? So that's where we have two categories. Electrochemistry is everything is related to electrochemistry. In the name itself it is there. It is the branch of chemistry which deals with the electric current, formation of electric current or utilization of electric current. So formation of electric current due to some chemical reactions or utilization of electric current to make some reactions to happen. So that's why we have the electrochemistry which deals with these particular reactions. Okay. Now when I am talking about this condition, we have two types of electrochemical cells. So we have two types of electrochemical cells. So one is Daniell cells, which can also be called as electrochemical cells. Will be two types. One will be Daniell cells or voltaic cell or galvanic cell, and in another case it will be electrolytic cells. So in this category, due to the chemical reaction, there will be formation of a voltage. In this category, to make the reactions to happen, we have to supply the external voltage. So that's why we have the two types of electrochemical cells. Hagadre, when I am talking about electrochemistry, when I am dealing with electrochemical cells and all, in that case, why galvanic, voltaic and Daniell? Why three different names? I am going to explain that one, but before that, you should know what you mean by anode and what you mean by cathode. If I want to draw the diagram of a particular cell, so there will be two containers, right? There will be two containers where electrolytes will be present. In these two containers, there will be presence of electrolytes. There will be presence of electrolytes. Okay, so this is also electrolyte. It can be a different one. I will call this one as electrolyte 1 and I will call this one as electrolyte 2. Now these solutions will be having electrodes, a metal rod dipped into them. There will be presence of a solid material which will be dipped into them, which we will call it as an electrode. Which we will call it as an electrode. Now, these two solutions, it will be linked by a bridge, which we will call it as a salt bridge. Which we will call it as a salt bridge. Now, as the name itself tells, it is a bridge. So, what kind of bridge? Bridge is nothing but which is connecting two terminals, right? So that's why they are connecting electrolyte 1 with the electrolyte 2. So that's why we have the salt bridge. Now these electrodes, they are connected to external circuit. They will be connected to external circuit. So that's where we have the a particular cell, electrochemical cell. Now, in this case, this electrode, I will consider this one as a anode. Always remember, whenever we are representing a cell, we are drawing the picture of a cell, anode should be written on the left hand side. Okay? And on the right hand side, it will be cathode. On the right hand side, it will be cathode. So we have two terminals, anode electrode and we have the cathode electrode. Okay? Now, if I think this one as a galvanic cell, if I think this one as a galvanic cell or a voltaic cell, okay? So if that is the case, I will be considering anode as a negative part. Anode as a negative part. If I consider this one as a galvanic or voltaic cell. And cathode as a positive part. Cathode as a positive part. Don't get confused. Okay? So now when I am talking about galvanic or voltaic cell, anode will be considered as a negative electrode and cathode will be considered as a positive electrode. But if I go with electrolytic cells, if I go with the electrolytic cells, whatever I have written, that is galvanic cell. If I consider the electrolytic cell, then it will be a reverse situation. Then it will be a reverse situation. All the other things will be same. There will be presence of electrolytes, no doubt. Okay? So there will be presence of salt bridge. There will be presence of salt bridge. Now, in this case, once again, left hand side it will be anode and right hand side it will be cathode, no doubt. Right hand side it will be cathode. But when I am talking about electrolytic cell, if I consider this one as a electrolytic cell, then I will consider anode as positive and cathode as negative. Anode as positive and cathode as negative. Okay, so what I mean to tell you is, in this case, in case of the galvanic or voltaic or Daniell cell, anode will be a negative electrode. We will be assuming anode as a negative electrode and cathode as a positive electrode. But when I am talking about electrolytic cells, anode will be considered as a positive electrode and cathode will be considered as a negative electrode. In most of the cases, we will be observing this one, right? So we should observe this one. But we have galvanic cell where due to the chemical reaction there will be generation of voltage. Okay? So just like our batteries and all. So that's where we have the galvanic or voltaic cells. And this is electrolytic cells. So what is that common in these? The common in these is with respect to electrolytic cells or with respect to galvanic cell, there will be presence of electrolytes, there will be presence of salt bridge, and there will be presence of electrodes. So when I am talking about electrodes, they are going to provide the surface. They are going to provide the surface for the reactions to happen. They will provide the surface for ions to get deposited, which will convert it into respective metals, and they will start getting deposited. That's where they are going to provide the surface. That is the role of the electrodes. In some cases, electrode itself can be involved in the reactions. With regard to our requirement, design will be done. Okay? So that's where we have the electrodes which will provide the surface. When I am talking about electrolytes, so electrolytes are those solutions. It can be a solutions or it can be in molten form. Anything is fine. So it can be a solution that is liquid or it can be in a molten state. So these are the molecules or these are the compounds which are solutions or in a molten state which has the capacity to conduct the electricity. So they have the capacity to conduct the electricity. Okay? They have the capacity to conduct the electricity. That's why they are used in the formation of galvanic or electrolytic cells. It will be utilized because they have the capacity to conduct the electricity. Okay? So once again, I will repeat, don't join first PU students. Dear students, it's not for you people. It's for second PU students. Okay? So you can use this time for your reading purpose. Anyway, it's up to you. But this is not meant for the first PU. This is meant for the second PU and it's a revision class. Okay? So that's where we have the electrolytes which can be in solution form or it can be in the molten form. If they are in solid, we will call it as conductors. But since for liquid, it will be electrolytes. Okay? So they are going to generate the ions. They are going to generate the ions, that is positive ion and negative ion. Okay? So that is the speciality of the electrolytes. They are going to form the ions, positive ions and negative ions. And all of us we know that positive ions will be cations and negative ions will be anions. All of you have understood? So please go through with the definition of electrolytes. Okay, they have asked, and in that case we have two categories, weak electrolyte and strong electrolytes. So weak electrolytes are those which will be partially dissociated into ions. For example, if I take acetic acid, now this particular molecule, when it will be added to the water, okay, it will be getting converted into acetate, a negatively charged ion, and positively charged ion, that is H+. But we can observe there is a reversible condition. So that means it is a weak electrolyte. Acetic acid is a weak electrolyte. But if I take HCl, it will be dissociated as H plus Cl minus. So single arrow, forward direction, right? So that means it is a irreversible. So therefore HCl is a strong electrolyte. All of you have understood? HCl is a strong electrolyte. So that's where when it comes to the electrolytes, we have two categories. Strong electrolytes and weak electrolytes. Fine? Now in that case, what is the role of salt bridge? Salt bridge will allow chemical reactions or this particular conduction of electricity can be happen continuously. They will not allow this process to halt it, to reach to the equilibrium. Because whatever ions will be formed, they will pass through this one and they will come this side, and the ions will be passing across the salt bridge. So they will help in continuation of the process. They will not allow this process to reach to the equilibrium. They will allow this process to reach to the equilibrium after long time. That is the role of salt bridge. Okay? Fine. So that's where we have the anode. That's where we have the cathode. So that's where we have the electrolytes and electrodes, and with respect to salt bridge. So one thing you remember that when it comes to galvanic cell, anode will be negative, cathode will be positive. You will understand that one when I will be taking the example. When I am talking about electrolytic cell, it will be reverse. Anode will be positive and cathode will be negative. Okay. Now I am going to write the Daniell cell, which is nothing but galvanic, a type of galvanic cell only. Now I am using the word type of. That means galvanic cell is a broad term. Voltaic cell is a broad term. Under that category we have the Daniell cell. Okay, under that category we have the Daniell cell. When I am talking about Daniell cell, that's where we have the anode and that's where we have the cathode. Okay. Now this will be the representation. Now this particular electrode, it will be a zinc. This particular electrode, it will be copper. Okay. So that's where Daniell cell. Daniell cell where anode will be having zinc electrode and cathode will be having copper electrode. So those voltaic cells where anode will be zinc electrode and cathode will be copper electrode. So those type of voltaic cell will be called as Daniell cell. Okay, it's very specific. It is dealing with only with respect to zinc and copper. It's going to deal with the zinc and copper. Now, electrolytes will be used in such a way that it will be having zinc ion in its solution. Electrolytes will be used in such a way that it will be having zinc ion in it. That's where we have the electrolyte, where zinc electrode has been dipped. So what is there in this particular electrolyte? There will be presence of zinc ion, Zn+2. Now on the other side, if I come, here also there will be presence of electrolytes, no doubt. Here also there will be presence of electrolytes, but here copper ion should be there. They will use in such a way that those electrolytes should have the copper ion. A simple example can be copper sulfate, zinc sulfate, right? So when I am talking about zinc sulfate, whenever they are dissolved or added to the water, they will become zinc+2 aqueous and they will become sulfate -2 aqueous. So that's what zinc+2 is present. Okay? Same logic is applicable here. Copper sulfate, if I take, whenever they will be added to the water, they will be associated as cupric ion plus sulfate ion aqueous. Fine. So that's what one of the example for the electrolyte. copper sulfate solution, zinc sulfate solution. So in solution form, copper sulfate will not be present as CuSO4. It will get dissociated as cupric Cu plus 2 and sulfate ions. Same way zinc sulfate, it will get dissociated as zinc plus 2 and sulfate ion. Okay? So that means in these electrolytes, on the right hand side there will be cupric ion and sulfate. On the left hand side it will be zinc ion and sulfate. Okay? So that will be the electrolytes which will be used. Naturally there will be presence of the salt bridge. Naturally there will be presence of the salt bridge. Now when I am talking about anode, since the Daniell cell is a type of voltaic cell, whether it should be anode should be negative or positive. Anode should be negative or positive because Daniell cell is a type of voltaic cell. So anode should be negative and cathode should be positive. Cathode should be positive. Now I will give the explanation why anode will be considered as a negative electrode. The reason is very simple. Anode is the one which is going to generate the electrons, which is going to release the electrons, and there will be movement of electrons towards the cathode. There will be movement of electrons towards the cathode. Since electrons are negatively charged, since they are generated at anode, by considering that we assume that anode will be negatively charged or negative electrode. Okay? And cathode will be a positive electrode. So why anode we are considering it as a negative electrode with respect to Daniell cell? Because that's where there will be formation of electrons. All of you have understood? Now, in this case, in this particular condition, we have two half cells, one half cell, another half cell. So if I divide this one with imaginary line, if I divide this one, I will consider this one as half cell 1, that is anode half cell, and this will be cathode half cell. Okay? So two half cells coming together to form the electrochemical cells. When I am talking about this half cell, each half cell will be having their own redox couples. They will be having their own redox couples. So in this half cell redox couple will be zinc plus 2 and zinc. Zinc plus 2 and zinc. Please remember, whenever we are representing the redox couple, oxidized part should be written first. Then the reduced part should be written. So therefore it will be zinc plus 2 and zinc. So when I am talking about another side, so redox couple will be represented as cupric ion and copper. Cu plus 2 and copper. So all of you have understood? So that's where we have the half cell. Two half cells will come together to form one electrochemical cell. So therefore they are considered as half cells. Now when I am talking about half cell, in first case it is redox couple will be zinc plus 2 and zinc. And whenever we are writing the redox couple, oxidized form should be written first, then comes the reduced form. Same logic is applicable on the other side also, where oxidized form will be cupric ion and reduced form will be copper. Okay? So once again I will tell, this is not for first PU, this is for second PU students. Okay? So that's where we have the redox couple, and that's how it has to be represented. Now we will go to the representing the cell. How to represent a particular cell? Representation of a electrochemical cell or galvanic cell or Daniell cell in this case. Representation of a Daniell cell in this case. Now whenever we are representing the cells, not by the diagram, by the equation form. If I want to represent, first I should go with the anode, then I should go with the cathode. Okay? Now if I see this one, first I will go with electrode. Now electrode is in contact with the ion, okay, electrolytes. Then through this salt bridge it is connected to ions, then the electrodes. Observe it carefully. First electrode, then the solution where ions are present, then we have the salt bridge, then once again solution with ions, then another electrode, that is cathode. So therefore, which is that anode, which is that electrode in this case? That electrode is zinc. Okay? Now zinc is an electrode, therefore it is a solid. It is a solid. Now it is in connection with the liquid. There is a change in phase. So solid and liquid, there is a change in phase. So therefore, I will connect it by one line. Then it is in contact with the zinc ion. Because zinc ion is one of the ion present in that particular electrolyte. I will be interested in zinc ion. Okay? So that's why we have the zinc ion. Now they are connected through a salt bridge. Therefore, double line indicates the salt bridge. Then comes the another part, that is once again ion. That is cupric ion, which is aqueous. Since we are dealing with the solution, aqueous. Now it is in contact with the metal rod, that is copper. So once again there is a change in phase, and that's where we have the copper. So this is how we are going to represent the Daniell cell. This is how we are going to represent the Daniell cell, a type of voltaic cell, where zinc plus 2 and zinc will be at anode part, and copper plus 2 and copper will be at cathode half. So anode half and cathode half together, they are going to form the Daniell cell. Fine? All of you have understood? This is how a cell can be represented, and on this you can expect the question. For the representation of a electrochemical cell, you can expect the question. You can expect the question on electrolytes. You can expect the question on salt bridge. 1 mark question I am talking about. Okay? So that's how we have the representation of the Daniell cell. Then we have another concept which is called as half cell reaction. We have another concept which is called as half cell reaction. Naturally, in the name itself it is there. Half cell reaction means a reaction which will be taking place in their respective compartment. That's why it is called as half cell reaction. At anode, what is happening? At cathode, what is happening? That's why it is called as half cell reaction. So therefore, at anode, first we will go with the anode. At anode, what is happening? At anode, zinc is going to donate the electron, and itself it is becoming zinc ion, and there will be release of 2 electrons. There will be release of 2 electrons. That means a zinc electrode, where zinc is donating the electron, and it is becoming zinc ion. It is becoming zinc ion. That's where electron has been generated at anode. Electron has been generated at anode. Therefore, negative. We will assume it as a negative. That is the reason. Now, what is happening at cathode? Another half reaction. At cathode, what is happening? We have the cupric ion, which is present in the electrolyte. It is taking up these 2 electrons, which is coming from the anode, and itself it is becoming copper. That means zinc will be released into solution as zinc ion, and cupric ion will be converted into copper, and it will start getting deposited at cathode electrode. All of you have understood? So that's what it is happening. Zinc, which is a part of the electrode in a solid form. Now they will donate the electron, and itself they will become zinc ion. That means they will be entering into the solution, and whatever at cathode cupric ions are present, they will take up the electron and they will become copper. So they will start depositing at the copper electrode. So after long time, what do you expect with respect to the size of the electrodes? What we expect? So after repeated usage, we can see that there will be decrease in the size of the anode, that is zinc electrode, and there will be increasing in the size of the cathode, that is copper electrode. There will be increasing in the size of the cathode and there will be decreasing in the size of the anode. Why there is a decrease in the size of the anode? Because zinc is getting converted into zinc ion. Why there is an increasing in the size of the copper electrode? That is because cupric ion is getting converted into copper. So that's what it is happening. Okay. So now these two are half reactions. Together they will give cell reaction. With respect to the Daniell cell in this regard. They are going to give the all together they are going to give the cell reactions. Okay. So what is that cell reaction? So we have the zinc, which is solid. Then we have the copper, which is aqueous. Okay. Now in the product, because these two electrons, it will get cancelled. They are equal opposite in the equation. So therefore, on the other part, it will become zinc plus 2 aqueous and copper as the solid. So this is called as a cell reaction. Hagadre, when I am talking about cell reaction, what is that cell reaction? Cell reaction is nothing but overall reaction of half cell reaction at anode and half cell reaction at cathode. So overall reaction will be called as cell reactions. Fine? All of you have understood? Okay? So hagadre, when I am talking about cell reaction, since it is a voltaic cell, since it is a Daniell cell, a type of voltaic cell, naturally there will be formation of voltage and that voltage will be 1.1 volt. That voltage will be 1.1 volt. Okay, na? So 1.1 volt. That means whenever zinc is going to donate the electron, to the copper ion, there will be formation of or generation of 1.1 voltage. Okay, so that's what it will happen with respect to the Daniell cell. Okay, so naturally there will be flow of current in opposite direction. Current will be represented symbolically as I. So there will be flow of current in the opposite direction, opposite to that of the electrons flow. So that's where there will be generation of 1.1 voltage. Fine. So which we will consider as cell potential. So which is nothing but 1.1 voltage in this case, where we have taken zinc at the anode and copper and its ion at the cathode. Fine. So therefore, when I am talking about E cell, that is cell potential, it can be equal to, observe it carefully, E right, cell potential of right half minus cell potential of left hand half. So what do you mean by that? That is, E cell potential will be equal to E right is what? That is cathode. Okay? So potential of cathode minus potential of anode. That's how a cell potential can be calculated. You can expect a question on this, where they will give the value of a cathode and anode, that is half reactions. Then you have to calculate the cell potential. So during that time, you should remember this equation where cathode will be represented first, then comes the anode. So right minus left. Right side is cathode, left side is anode. Don't get confused. So when you are representing a cell, when you are drawing the picture of a Daniell cell, Anode will be on the left hand side, cathode will be on the right hand side. That is the standard accepted procedure. You have to draw in the same pattern. Okay? So where anode should be on left hand side, cathode should be on the right hand side. Then anode should be having negative, we will assume, and cathode as positive. That is one thing. When we are talking about redox couple, always oxidized part will be written first, then comes the reduced one. Same logic here also. Oxidized first, then comes the reduced one. Now that's how a representation of a cell will be done. Where anode will be written first, then comes the cathode, because we are moving from left to right direction. We are moving from left hand side to right hand side direction. Therefore, cell representation will be like that. But when we are calculating the cell potential, the right hand side, that is cathode, will be written first, and then comes the anode. So whatever cell potential, half cell potential will be given, it has to be filled in here, and you have to calculate the cell potential. Okay? All of you have understood? So that's how a cell potential can be calculated. Now, next question here will be, what do you mean by EMF? What do you mean by EMF? Right? That's the question. So what do you mean by EMF? Or we can represent it as like this. EMF means electromotive force. Okay? So now EMF is nothing but a cell potential. EMF is nothing but a cell potential, but when there is no voltage which will be supplied, or there will not be any formation of any voltage. So that condition is whatever potential will be there, that will be called as EMF, electromotive force. So please remember, whenever we are talking about the questions, it can be related to electrolytes. Okay? So it can be related to electrodes. One mark question. About this they have asked. It can be related to salt bridge. It can be related to salt bridge. Then it can be related to half cell reactions. Based on that you can expect the question. Half cell reactions. Then it can be related to redox couples, representing the redox couples. Then it can be related to representation of electrochemical cells. So this one they have asked related to that. Then it can be definition of EMF, they have asked. It can be definition of cell potential. It can be related to cell potential, they have asked. Then it can be related to electrode potential. It can be related to electrode potential. That one also they have asked. So like that, for 1 mark you can expect the questions. Like that, for 1 mark you can expect the questions on this concept. Fine. All of you have understood? Then we will move to the next one. So when I am talking about anode and cathode, when I am telling that there will be flow of electron from zinc to the copper, there will be flow of electron from zinc to the copper, who is going to decide? Who is going to tell that zinc is going to donate the electron to the copper? That is based on electrochemical series. For example, we have zinc ion, okay, which is aqueous. When it will take up the 2 electrons, it will become zinc. So this is what we have seen as one of the reaction. Same way we have copper ion. I am not talking about another half cell reaction. I am writing separately. There will be formation of the copper. Fine. Now, when I am talking about these 2 reactions, both will be having particular redox potential. Both will be having a particular redox potential. Both will be having a particular redox potential. Now when I am talking about redox potential, naturally the unit should be written in terms of voltage. It will be in terms of voltage unit. So that's where we have the zinc ion accepting the 2 electron and becoming zinc. Copper ion accepting the 2 electron and becoming copper. Both will be having their respective redox potential. Both will be having their respective redox potential. We will call it as standard redox potential because E naught. That is the difference between E and E naught. So this is nothing but standard redox potential. Okay. So what do you mean by standard redox potential? Where redox potential has been calculated under the standard condition, that is when we have taken 1 molar of concentration of these molecules. When we have taken 1 molar concentration of these ions, these molecules. If I am talking about gaseous molecule, it should be 1 atmospheric pressure. Sorry, not 1 atmosphere, 1 bar pressure. It will be 1 bar pressure. If I am talking about gaseous molecules, we are taking the 1 bar gaseous, gaseous molecules with respect to 1 bar pressure. So that's why it is called as standard redox potential. When we are having calculation under this condition, where 1 molar we have taken the concentration or 1 bar gaseous molecule we have taken, under that condition whatever redox potential will be calculated, that will be standard redox potential. Okay? So when I am talking about copper ion becoming copper, it will have the positive value. Copper ion accepting the 2 electron and getting converted into copper, that will have the positive value. When I am talking about zinc ion becoming zinc, it will have the negative value. All of you have understood? It will have the negative value. What is that value? We will not be bothered. But please remember that one will be having positive value and another one will be having negative value. So which is having positive value? Zinc ion taking 2 electron and becoming zinc. They are having negative value. What about this one, where copper is accepting 2 electron and having positive value, where copper ion will become copper. So now, what is the significance of these values? What they tell us? What will happen if we have the redox potential value as negative? What will happen if we have the redox potential value as positive? What it indicates? First and very important point here is, we have an equation called as delta G naught is equal to minus NF delta E naught. Okay, this is the equation which in later part of this topic we are going to discuss. If I have the redox potential value as a negative, now what will happen? The total value will become positive. Whenever delta E naught value will become negative, delta G naught value will become positive. All of you have understood? Because negative, they will become positive. So in this case, in second case, where minus NF delta E naught. So in this case, since there is a positive value, delta G naught value will remain negative. Okay, delta G naught value will remain negative. All of you are understanding? So this is the equation. Delta G naught is equal to minus NF delta E naught. So what do you mean by delta G naught? Gibbs free energy. Thermodynamics, you people have studied in first period. Delta G naught is nothing but Gibbs free energy. So what do you mean by N? N is the number of electrons which are involved in the process. In this case, it is 2 electrons which are involved. F is Faraday's constant and delta E naught is change in the redox potential. Change in the redox potential. If that change in the redox potential, if it is becoming negative, then negative will become positive. Delta G naught value will become positive. Now delta G naught value will become negative because here we have the delta E naught, that is redox potential, as positive value. Now all of us we know that when the delta G naught value is positive, that indicates that it is a non-spontaneous process. It is a non-spontaneous process. That means this process will not happen so easily. And whenever delta G naught value is negative, it indicates that it is a spontaneous process. It is a spontaneous process. All of you are understanding? That's where we have the non-spontaneous process, and that's where we have the spontaneous process. Why we are telling it as a non-spontaneous process? Because delta G naught value is positive. Why we are calling it as a spontaneous process? Because Gibbs free energy value is negative. That's where we have the non-spontaneous and spontaneous. Now based on this statement, what we can conclude? We can conclude that zinc is the poor acceptor of electron. Poor acceptor of electron. Okay? And based on this we can tell that copper ion is the good acceptor of electron. Acceptor of electron. All of you will agree? Because cupric ion becoming copper. Okay? So that's why it is a spontaneous process. That means they are going to accept the electron easily. But zinc ion becoming zinc, they are having positive delta G naught value, non-spontaneous. Therefore, they are poor acceptor of electron. All of you have understood? Therefore, when we were representing the Daniell cell, zinc and its ion, we assume that one as an anode because that's where they are going to donate the electron. Now if I write the reverse reaction, okay, now E naught value will also become reverse. That means negative value will become positive. Negative value will become positive. That's where it will become a spontaneous process now. It will become a spontaneous process. Try to understand this one. It will help you in your competitive exams also. So that's where we have the zinc becoming zinc plus 2 and 2 electron. It's donating. That electrode potential, redox potential will also become positive. Negative value will become positive. When we have reversed the reaction, even value will be reversed. So therefore, zinc is going to donate the electron easily to the cupric ion. So based on that, we can tell that zinc is going to donate the electrons to cupric ion. Okay, all of you have understood? That's what we can give this statement over here. So according to this, zinc is going to donate the electron to the cupric ion. Reverse will not happen. Reverse will not happen. Copper is not going to donate the electron to the zinc ion. No. Reverse will not happen. It will be the zinc which is going to donate the electron to the cupric ion. That is Cu plus 2. Fine? Any doubts in this? So that's where we have the reactions. All together we can call them as redox reaction. All together we can call them as redox reactions. Why redox reaction? Because there is a reduction, there is an oxidation. So reduction is with respect to cupric ion. So cupric ion is getting reduced to copper. What is that oxidation? Oxidation is nothing but zinc is becoming zinc plus 2. So there is the oxidation of zinc and there is a reduction of cupric ion in this case. All of you have understood? Any doubts in this regard? Okay. So anyway, So tomorrow we are going to continue with the next concept and we will solve some of the questions related to this concept. Fine? So we will solve some of the questions that is with regard to competitive exam, means board exam questions related to whatever concept we are discussing. Fine? So that's what. Today we have discussed about how a cell can be represented, how a redox couple will be represented, then what is the definition of cell potential, electrode potential, right, half cell reactions, everything we have discussed. How to write the Daniell cell, that also we have discussed. Difference between electrolytic cell and voltaic cell we have discussed. So in the tomorrow's class, we will move further and we will solve some of the questions related to your exams. Fine? In that case, I will stop here. Thank you. Take care. Tomorrow. Yes, naturally. Oh, you are here only. This is not for you people, appa. It's for second PU. Fine? So it will be a recorded one. They will be watching later. Okay, Vishwas? So tests will be there. Okay, na? Thank you then. All the best. Take care.